This video will be talking about part 1 of solving systems by substituting. So this is day 1, unit 3.3 on systems. Okay, so substitution. So you guys actually learned about substitution back in middle school in 8th grade. Whether you remember or not is up to you, but you did learn it at some point. And basically what you're doing is you're creating a situation where you can solve for more than one variable. So normally when I have this, okay, I move 5 to the other side, I divide by -3, get an answer for x. Awesome. However, when I put a y right there, I no longer can solve for one of my variables and get a number. With 2 variables, you need 2 equations. If I have 2 equations, then I can do some work with that. I can either eliminate stuff or I can substitute things in to figure out what one of the variables is. So we're going to be talking about the substitution route. Substitution is just another name for replacing or exchanging or taking the place of. Any of those synonyms work for the word substitution. Right? And what we're doing is finding a solution to 2 lines, basically. So when you have 2 equations, if they cross at one spot, that's kind of what we'll deal with normally. When they cross at no spots, they are parallel because they have no solution. And when they happen to overlap on each other, they have infinite solutions because they're the exact same line, which makes sense. Okay, so think about substitute teacher. Here's a lovely picture of a crazy looking substitute teacher, sorry. Substitute is somebody who takes the place of your regular teacher, who steps in for them for a while. Okay, so substitute teacher. All right, so pause here, copy these down, and then I'll try and explain a little bit what those mean after you're done writing. First step, when you're solving for a variable, you're really trying to get it by itself. Get x or y by itself. That's really what solve for a variable means, just like in normal algebra. Substitute the expression from step 1. So once you have y equals 2x minus 1, you're going to replace using that expression. Expression means more than one term. It's not just 1. It's not just the number 3. It's 2x minus 1 or x squared minus 7, some kind of expression. And then step 3, substitute the value that means an actual number. Okay, so we're going to get an actual number from step 2, plug it in to get the other variable. So you're solving twice this time. A little bit more work than we're used to. Alright, so example 1 actually already did step 1 for us. They have y by itself in both equations. So I'm just going to pick the first one, and it tells me y is equal to x minus 10. Well, that means wherever I see a y in the other equations, I can just put x minus 10 in its spot. Okay, I'm substituting it in. Again, it tells me y is equal to this, so sub it out. Get rid of it. Okay, so instead of y equals negative 6x plus 11, I'm going to keep everything else, but instead of y, I'm going to substitute in x minus 10. It told me that's what y is equal to, so I can do that. From here, now I have x in my entire equation, so I can actually start to solve it. So my first step is going to be to add 10 to both sides. So I'm trying to get x by itself. Okay. Well, now x is by itself on the left-hand side. However, I still have this 6x that I have to deal with. So I'm going to move that over here. Again, this is algebra view. This part is not brand new. You should know how to get x by itself. Some of you can actually probably already figure this out on your own without me walking you through it. But no matter what route you take, if you moved 11 first or moved the 6x first, it doesn't matter. Either way, you should get 3 for your final number for x. Now, normally we're kind of patting ourselves on the back and saying, yay, we're done. But we have 2 variables this time. Okay, so let's go back to our steps. We have solved for a variable. That was already done for us. We substituted that expression in to get x equals. We did that. Now I got to take this value, 3, and sub it in to my original equation. So basically what I'm going to do is it tells me x is equal to 3, so I'm going to go back up to this equation. Y equals x minus 10, my original equation that I was using to sub in. Well, I already know what x equals now. It equals 3. So in place of x, I'm going to put 3. Everything else stays the same. All I've done was sub that in. Well, that's pretty easy math. 3 minus 10 is negative 7, which means that that is what y equals. X is equal to 3, y is equal to negative 7. And if I was to plug those numbers into that equation, it would work out to balance each other on both sides. Pretty cool. Okay, pause here. You're going to try number 2, but I'm going to tell you right now it's going to work out a little bit different than we're used to. So don't be surprised when you see something doesn't quite work out like we planned, and then see if you can figure out what does that mean about the equation. So pause here, try number 2, and then I'm going to go through it. Alright, so you should have paused and at least tried it on your own. You might have figured out what the issue is. So let's start with this. It says y equals 2x minus 2, so sub it in. 2x minus 2 now equals 2x minus 1. So some of you might have already picked up on the issue just from looking at that, but we'll do a little algebra to help it along if you're not sure. So let's say I subtract 2x from both sides. When I do that, 2x minus 2x cancels out. That's gone. But on the left-hand side, it's also 2x minus 2x, and that goes away. Well, that's a problem because now I only have negative 2 on this side, and I have negative 1 on that side. Does negative 2 equal negative 1? No. That's not a true statement. And since I can't go any further, this actually means no solution. So think back to those slides I showed you at the beginning. What does it mean if two graphs have no solution? That means that their lines never what? Hopefully in your head you're saying they never cross. If two lines don't cross, they don't have a place where they intersect. There's no solution. What do we call two lines that do not cross? Hopefully in your head you automatically said parallel lines. That's what it means about those two equations. Okay, y equals 2x minus 2 and y equals 2x minus 1 are parallel lines. No solution. Moving along to number 3. All right, so this one, again, let's check our steps. Solve for a variable. Get x or y by itself. Sweet, they already have that done for us. In the second equation, it says y equals this. That means y is by itself. I don't even have to do that step 1. Okay, I do have to know that that is going to replace y in this equation. Okay, now look here. This one's kind of weird. Last time we had the y by itself when we swapped it out, but this time it's being multiplied by 6. What do we have to put around that group in order to keep it a group when I sub it back in? Parentheses. So it looks like that when we sub it back in. Looks kind of weird, but really I just took this equation. Instead of y, I put what they told me y equals, negative 3x plus 23. Some of you guys have already figured out what our first step is. We have to do what with the 6? We have to distribute it. 6 times negative 3x is negative 18x. 6 times 23 is 18, 31, 138. And then remember that everything else gets dropped down. So there's still negative 4x. Still equals 6. But now I have x in numbers. I can solve for x by itself. Okay, so first step, you can go ahead and try this on your own. You don't need to watch me do it. You know how to do algebra. But if you need some help, go ahead and watch. First step I see is to combine like terms. Negative 4 and negative 18 is negative 22. And then I have plus 138 equals 6. Okay? Getting closer to x by itself. Got to get rid of that 138, so I'm going to subtract it from both sides. So I have negative 22x equals 6 minus 138 is negative 132. Last step to get x by itself. Hopefully you're kind of getting the hang of it with the algebra steps. You should know how to do those. You should get either in your head or on your calculator that x is equal to positive 6. Make sure you keep it positive. If you change the sign, you're going to ruin the whole rest of the work. Okay, now again, normally we're done. X equals 6. Woo, we finished. Okay, but we still have to solve for y. So I'm going to go back to this one, the one where y is already by itself. Don't pick one where y isn't by itself. You're making more work. Pick one where y is already by itself. We figured out down here that x is equal to 6, so in place of x, put 6. This should be the easiest part of this section, is because you're just subbing it in and solving. Negative 3 times 6 is negative 18. Add it to 23, and we get y is equal to positive 5. Woo! So there's our solution for that problem. And actually, when you put those two numbers together, that is the spot on a graph where those two lines would cross. 6, 5, because this is x, this is y. That is where the two lines would cross if I was to graph those lines. That's what that means. Okay, last example for today. You're going to pause right here, make sure you've got all your work copied, and then you are going to try number 4. Okay, do it without watching the steps. You can do this on your own. You are capable of at least starting it on your own. Give yourself that opportunity to learn, to struggle, to make mistakes. So pause here. When you're ready, hit play, and you can check your work and see how you did. Make sure you got it all right. All right. Hopefully you at least try it yourself. No cheating. Don't cheat yourself out of learning. Do it yourself. Okay? Tells me that y is already by itself. Awesome. I didn't have to get it by itself. We'll do that on the next lesson. But it tells me y is equal to 8x minus 7. That means in the first equation, I got to replace y with 8x minus 7. I don't think I said that the first time. 8x minus 7. So I'm going to rewrite this guy. 8x minus 2. If I have 2 multiplied by that, make sure you put your parentheses. Don't forget about that. If you didn't do that, you probably ran into some problems. From there, you should have distributed. Pay attention to the fact that it's a negative 2. You might have had some issues if you did not use that negative. So negative 2 times 8 is negative 16x. Negative 2 times negative 7. Oops, I forgot the x there. X. And then this is plus 14. And then everything else drops down like before. All right, start to combine our like terms. I see 8x minus 16x, negative 8x plus 14 equals 14. Don't panic with this next step, okay? Don't panic. Subtract 14. You get negative 8x equals 0, which is okay. You can have it equal 0. Do not panic when you see that. Okay, I'm still getting x by itself. Follow your normal steps. Don't let the 0 frazzle you. All it means is that x equals 0. That's okay. 0 is a number. It's possible for that to happen. But please remember, you're not done yet. X is only part of our equation. We have to solve for y still. So take that 0. We know x equals 0. Bring it on back up here to this equation, which already has y conveniently by itself. Plug it in for x. So we have 8 times 0 minus 7. 8 times 0 is 0. Minus 7. That means y equals negative 7. So they cross at 0, negative 7. Woohoo! All right. Check the announcement on the Google Classroom section to see what problems you're going to do on the backside for tonight's homework. Feel free to rewind and check and see if you need to look back at some others for some extra help. We will complete this notes on the next day's worth of class.